Passengers of a Boeing 737 were jolted awake in the small hours of this morning as it came crashing down just short of the runway.
Have you ever wondered how airplane engines are proven to be safe and reliable before they carry hundreds of passengers across the skies? To ensure every engine can withstand the toughest conditions, it undergoes a series of extreme tests. These tests are designed to simulate real-life challenges an aircraft might face during flight. From blasting water into the engine at high pressure to firing dead birds directly into it, each trial aims to push the engine to its limits. But why do engineers go to such extremes? Understanding the rigorous process behind these tests not only highlights the importance of safety in aviation, but also reveals the fascinating science that keeps us safe in the air. Let's dive into how and why these unusual tests are conducted to ensure the reliability of airplane engines. Water testing engineers have developed numerous engines over time, each with unique enhancements and changes to ensure their effectiveness. However, every engine must be capable of enduring various conditions, including excessive heat, rain, snow, and ice. These engines, they undergo water ingestion tests, which force a stream of water into running engines at a rate of 350 gallons per minute. If the engine passes the water test, it is expected that the water will be removed without causing any damage to the engine or its operation. When temperatures drop and weather becomes colder, icy conditions pose a greater risk to the engine, necessitating the use of various ice particles. Large ice balls are thrown into the engine to determine its tolerance and recovery speed. Hot and cold tests are also conducted to assess the engine's ability to function well at high altitudes and extremely high and low temperatures. To test the engine in cold temperatures, they are transported to a location with temperatures as low as -28 degrees Celsius in Canada's Nunavut territory. The engine is left there for a week, testing on the ground and in the air, running thrust reverse tests with snow, and determining how long the engine can continue to function effectively in such conditions. Engineers have developed numerous engines to meet the demands of nature, but they must also be capable of enduring extreme conditions like extreme heat, rain, snow, and ice. Bird testing aircraft manufacturers are required to conduct unique and necessary tests to prevent bird strikes, which can lead to accidents. There are numerous ways an airplane may crash with a flock of birds traveling in the same direction as the aircraft. In rare cases, a bird may directly hit the engine, causing significant damage and requiring an emergency landing. To prevent this, manufacturers have invented a way to smash the like button. Engines must also undergo tests to prevent bird strikes and their damage. A chicken gun is used by engine manufacturers to simulate the impact of birds in the sky. Dead birds are fired into the engines while they are still on the ground, allowing for testing and ensuring the windshield's durability. Manufacturers have developed various strategies to ensure that bird hits do not result in substantial damage. The only exception is the bird itself, which has its own set of strategies to address various problems. Birds can become completely absorbed into the main engine, but this does not affect the engine's ability to work or perform its functions. While these crashes do not result in fatalities, they can cause engine failures or minor damage that can lead to subsequent difficulties. An incident of this kind of bird strike led to an emergency landing on the Hudson River in 2009, where the flock of birds successfully turned off both engines, resulting in the plane landing on the runway. Despite no injuries, the bird strike was successful in turning off both engines, demonstrating the importance of bird safety in aviation. Blade-off testing. The blades in an aircraft engine can rotate at high speeds, reaching up to 3,000 revolutions per minute. This allows the engine to generate maximum force and power, enabling it to lift the airplane off the ground and into the air. However, these blades must be installed securely and carefully, with careful attention paid to each individual blade. During the blade-off test, the primary purpose is to ensure that every blade remains securely attached within the engine and there is no risk of any blade escaping. In the air, it is not acceptable for a blade to become dislodged or fly out of the engine. However, certain engines have experienced this issue before attaching the engine to the airplane. If a blade detached from the vehicle at approximately 3,000 revolutions per minute, it would cause more damage than a bird attack would. The goal of these tests is to ensure that the blades are properly fastened in position and cannot fly out of place, as this could potentially cause fatal harm to passengers. Even if one or more blades fall out of the engine should not sustain considerable harm. During the testing procedure, one of the blades is fitted with a miniature explosive device that is detonated immediately after the engine is put into operation to determine whether the blade will continue to be confined within the engine chamber. Engineers return to the drawing board if one of the blades is removed from the engine while it is being tested, and they repeat all of the tests again, using a smaller blade. Even a seemingly small object, such as a finger, can inflict considerable damage to the engine and fuselage of the airplane while in the air, potentially due to an accident or emergency landing. Lightning testing. Lightning is a highly probable threat to commercial airlines, even if not in the midst of a storm. However, there are effective ways to prevent lightning damage to aircraft. On average, a flash of light strikes each commercial airliner around once a year, but many continue their flights without concern. Lightning can cause explosions, which can cause significant damage that cannot be repaired and could have catastrophic consequences. In the past, lightning struck an engine, causing emergency landings or crashes to minimize the risk. Manufacturers have devised suitable protection for the aircraft and tested the engines to ensure they wouldn't shut down due to a simple strike. Materials like carbon fiber, which are lighter than aluminum, have a poorer electrical conductivity than metal. By using these materials on the airframe and engines, there is potential for a 25% improvement in fuel efficiency. However, to provide further protection against lightning strikes, a layer of metal mesh or foil should be applied. Although systems to protect the entire aircraft from lightning strikes are still being examined, the current situation has arisen. To ensure proper functioning of the engines, high-voltage tests are conducted to determine if they will fail or continue to function regularly. There is no need to worry about lightning strikes during flights, as they are unlikely to cause any significant damage. The implementation of effective methods to prevent lightning damage is underway, and the future of aviation remains uncertain. In-flight testing. The engine has undergone various tests, including ground tests, to demonstrate its structure. However, the final test is an in-flight test that analyzes its performance. Manufacturers use test beds, modified planes to conduct these tests. These tests are used to assess the engine's dependability in flight. An ancient Boeing 747 is also used as a test-bed airplane. These test beds are crucial in ensuring the engine can withstand the force of the aircraft. Despite their unusual shape, they are essential components in the testing process. During the flight, the engine is put through various tests, reaching its maximum speed and full thrust. It is also evaluated to determine its performance at higher altitudes compared to ground performance. The FAA will only approve and accept an engine after successfully completing all tests. Only then will it be considered for certification. After completing these tests, the engine can proceed to production, which is the next step in the certification process. The engine undergoes various tests to ensure its reliability and performance in flight. Test beds, such as the Boeing 747, are used to evaluate engines for commercial and business aircraft. This is it for today. We hope you enjoyed the video. If so, then share your thoughts in the comments and also share this video with your friends. Don't forget to subscribe to our channel and press the bell icon so you can never miss our video.